let's talk about another kind of sequences, geometric sequences and series. On your section 12.3, page 62. So far, we have been talking about arithmetic sequences and series, right? By adding some numbers to the next term. Then we said, okay, we are learning two types of patterns, simple patterns. One is by adding, subtracting numbers to get to the next number. Another one is multiplying and dividing. Okay, so we did adding and subtracting a number to the next number, right? So the sequence is a pattern, right? Then if add and subtract to get the next number, we call this one arithmetic sequence. And what's the formula? How do you find your general term? So that would be next general term, right? Will be a n equals, start from first term, then plus how many distance away, and minus 1, right? We are repeating many times. So hopefully you can remember. So for the sequences, we deal with what? First number, right? Then we need to have what? The distance, right? The difference. Then we need the nth term. Then index is n, then value is an, right? For the nth day, how many, various cases we can have. So for series means you add up all those days. Sequences are, for each day. Series is the sum of the total, right? So A1, A2, A3, all the way to the nth term, right? The total. So how do we write the total? We use Sn, right? If total up to the nth term, finite term, you will do what? N over 2, A1 plus An, right? Then same thing, we need what? For this one, we need to have n, we need to have A1, we need to have An, right? Then this is a finite series. If it's infinite, it doesn't exist, right? Because you keep adding or subtract number, there is no limit to what happened. So that will be your arithmetic sequence, right? How about geometric sequence? What are we talking about? Instead, you do add, subtract. We are going to do what? Multiply and divide with that kind of patterns to get the next number. Okay? So, let's see how we are going to use the notations and the definition to describe it. So geometric sequence is a sequence in which each term, right, after the first one, the next term will be obtained by what? Multiplying. To get the next term by a number r. Okay, r we call it what? Common ratio. Okay, for arithmetic sequences, we use the common difference. This one is by common ratio. So we have what? A1, A2, A3 to AN or to infinite, right? So the common ratio means what? How do we multiply this number to get the next term? So our R will be what? Next term divided by the previous term. So it can be A2 over A1 or A3 over A2, right? So formally we write it this way. The following term, AN plus 1 divided by the one before it, right? So we use this. Then how do we find the general pattern for the term like this is general term like that, right? So AN, that's what we want. We are going to find a formula to find the term, okay? So how are we going to write the term? Let's see some examples first, right? Then we summarize with the formula. So let's take a look. If we have a situation like this, first we decide, do we have this type of a sequence or not? From one to another, how do we get there? We multiply by 2, right? So we do have geometric sequence. The next number you will expect is what? 160, right? Because R is 2, common ratio. So how do we get R? We just do the first term, second term divided by first term. Easiest one. Or you can do third divided by second, right? If we have this one, 5/4, what do you think the next term would be, right? So we see if there is a pattern there. Let's take a look. That would be what? Divided by 4, right? Divided by 4. But instead of doing division, divided by 4 is that same thing as multiplying by 1/4. Are they the same? Right? So that's why we say multiply and divide. They have similar characteristics, okay? So our R would be what? Second one divided by first one, that would be 1/4. That's how we do, right? Then if we have this one, 3, -15, 75, -375, what do you think? Do we have geometric sequence? Let's take a look. So it seems like it. I can multiply by -5, right? So we would do R equals -15 divided by 3. That's how we get it. Then -5, -5. We get the following number. How about next one? Next 6, 6, -6, 6. Would you call this geometric sequence? Take a look. Can we make it happen by multiplying some number? -1, right? Is that right? So the way to find our R would be 6 divided by -6. That would be our -1, right? Okay, let's see. How can we find a formula? Mainly is this. So if we know this, we know the formula, and if we know the A1, we know the R, right? Then for the nth term, we should be able to find the AN. That's the idea. Okay, so let's see, how can we figure out? All right, so for this one, we have 5, 10, 20, 40, that's this one, right? 80. Right? So we see first one, or we can compare with, use the symbol, right? A1. First one is A1. Second one will be what? A2, A3, and so on. So A1 is A1, right? A2 would be what? So 5, first term is 5. 10 would be what? We multiply everything by 2. So it would be 5 times 2, right? So first one times your common ratio will be your next term. What's the next term? Will be A1 times another R, right? Another R, that would be A1 times R squared. Same thing, 20 would be what? 10 times 2, right? This one times 2 will be 5 times 2 times 2, right? Will be what? 5 times 2 squared. Is that right? That means the next term will be A1 times R squared. So then next term will be what? 40 will be what? 5 times 2 to the third, right? 5 times 2 squared times another 2 will be 5 times 2/3. Same thing, A4 is what? A1R third power, right? So second term you just times by 1R. Third term you times R twice, right? So what do you think? For A10th, what do you think it should be? A1 times R how many times? 9 times. Is that right? So what do we have? Same thing is here. So if we have AN, we use what? 5 times 2 to the how many times? Because second one 1 time, third one twice, third one, and the fourth one 3 times. So 1 time less. So it's n minus 1, right? Same thing here. AN should be what? A1 times R to the how many times? N minus 1. Is that right? So that's our formula. Okay? So the formula would be A1, we need A1, right? A1 for that times what? R to the how many times? N minus 1. That's the formula. Okay, like arithmetic sequence, right? Is what? Add difference n minus 1 time. But for common ratio, by multiplying, you multiply how many times? N minus 1 times of the R, right? Instead of adding. So that's the patterns we have for geometric sequences, right? So first we'll get our formula. Then we figure out, among all those numbers, we might give you first term, the common ratio, then how many terms, then you can find the terms, right? Okay, your R can be what? 2 or 1/4 or -5 or -1. Can be the number, can be a whole number, or it can be a fraction. as well, right? Okay, let's practice some of those. Look at your page 63. Let's see some example. So if I will have 28 16/5, 32, 25, okay? So first you have to decide. Now, not only one, we have two kinds. So you have to decide which kind you are dealing with. Then you decide which formula you are going to use, right? So let's find the formula for general term, then find the A14th term. Instead of what? You keep multiplying to find the number, right? So what do you think? Do we have geometric sequence? So what do you think? It's possible. So for R would be what? Second term divided by first term. That would be divided by 4, 2/5. Is that right? Without work? So you multiply 2/5, you get 8. You multiply 2/5, then you get this. Then you multiply 2/5, then you get the next term, right? So we do have a geometric sequence. Then we want to find a general term, right? First, we have to have R, right? Then we have A1, then we can find the rest of them. So we have A1 is what? 20, right? N is our general term. Okay, general term means this is some kind of number. An is our general term we want to find. So we just plug in A1 20 times what? R is 2/5, right? Then for some number n minus 1, right? Does that look familiar? It's like y equals 2 to the x power. Because your n, right, is on the power position. N will change, right? 1, 2, 3, 4, 5, 20, 30, right? So n is at the exponential position. So actually, for geometric sequences, they are exponential growth. That's what we have been dealing. Okay, so that would be our general term. You can just answer the number just like that. That's all you need. Okay, then second one, it says find what? That's our A, that's B. Find what? A14. So what do we do? All we need to do is just plug in here, right? 20, 2/5, and 14 minus 1. However, for your test, you cannot just leave number there because you need to simplify. You can just punch in some of your calculators can use fraction. You can just direct plug in. But you do need to answer the question with fractions. Sometimes you can answer with decimals. If you can have exact decimal, you can, but you cannot round it, okay, for the accuracy. So otherwise, you just do the decimal, fraction things, right? So you will be 20 times what? 5 and 2 to the 13 power. And if you don't know how to use fractions to find the answer in fractions, you need to call LTCC Tutoring Center. They are tutors free to show you. You better learn how to do it because you need, if you are going to take a pre-cal and calculus, you need how to use the calculator, right? Otherwise, you call me. All right, so what do we have? We have 20, then you can use, just separate them, things like this. Okay, then you cross cancel. After you have whatever the number you have, you should have this number. Make sure you practice this. Okay? Either you call the tutors or call me. We can straighten out all those. Let's look at the next example. If we have 2, -6, 18, -54, okay, we want you to find SA16. Okay, so do we have a geometric sequence? Yes, times by -3, right? Of course, you can use calculator 15 times to get a number. That's not the idea. That would take forever. And you won't be able to move on to pre-cal and calculus. And you need to learn how to use formula. One time we had a student, he just didn't want to use formula. He thinking, oh, I times 16 times, 15 times. So what? You get the right answer. That's not the point. Because if you cannot do the patterns, you can do it now. But when you go to pre-cal and calculus, you will be in trouble. That's why that guy, he just wouldn't do it. Then took him, 2 years just to finish 1 year calculus. Right? So you need to have these skills, pattern recognition skills, be able to do the formula. Okay? So you can move on to do more difficult things. Now, let's find the A16. So, what is A16? 16th, right? So we know A1 is what? 2. Then we need the R, right? So R is what? -6 divided by 2 is -3, right? Now N is what? For A16, then N is what? 16, right? So we plug in A16, we should have this one is A1, R is what? R to the N minus 1, right? That's why we also put a parenthesis for it, because sometimes we have a negative number. So A1 is 2, then R is -3, N is what? 16. So 16 minus 1. So we have 2 times -3 to the 15th power. It's a negative number. Okay? Make sure you punch into the calculators to get the number. You do need to practice. You just don't wait till, testing time. You don't have time to figure out. So you need to practice here, also on your homework. Right? So this is the formula we are using now for the geometric sequence. Okay? So, if we have this one, we say A4 is 7/4 and A5 is 7/6, right? Then, since we want to find the general patterns, we need to have A1, we need to have R. But for this one, we don't have it. So how can we find A1 and R first before we can move on, right? So how can we do it? Then we say R is what? The following term divided by the previous one, right? The one ahead of it. So you can do what? A5 divided by A4. Is that right? So 7/6 divided by 7/4. You should be able to handle this division, right? If you get stuck here, you are in trouble. Okay? You better work extra hard to figure out everything. So it means what? It means a division. Then how do you divide your decimals? Fractions? Reciprocal. Right? It's a 4/6. Then you don't want to use 4/6. You want to what? Use the simpler one where you calculate numbers. Okay? So that's R. Then what is A1? So we have A1, A2, A3, A4, A5, right? 7/6, 7/4 here. So it must be 7 over something, we will guess, right? Maybe, maybe not. Okay? So, because it doesn't look like. But anyway, so how can we find A1? Look at the formula again. So, because here says AN equals this, right? A1 and R. We don't know either of them. We do know R now, right? So if I do A4, what do I have? I should have A1 times R 2/3, right? To the n minus 1. So n is 4. That would be this one, right? Then what do we have? Do we know A4? Yes. A4 would be what? 7/4. A1, we try to find 2/3 to the third power is 8 over what? 27, right? Then we need to find the A1. You can divide each side by 8 over 27, or you can do it this way. You can just multiply its reciprocal here, 27/8, this way, then you can get A1 by itself, right? So that would be A1 is, multiply together is 189 over 32. You can do this way, right? You only need one of the numbers, A4 or A5, okay? Or we can do it this way. We can do it, say A5 equals what? A1 times 2/3 to the how many powers? So you multiply 1 time less, that would be 4, right? And minus 1. And A5 is what? 7/6. We try to find the A1 times this one is 16 over 81, right? Then to get A1 by itself, we can multiply this reciprocal, 81, 16, right? Then this one cancel by 3. Okay, so we end up 189, 32 equals A1. Do we have same answer? Yes. So you can do it either way, right? So we have 2 kinds of sequences now. One is arithmetic sequence, right? Another one is geometric sequence by multiplying and dividing some number. So we know the sequence's formula is what? AN equals A1 times R to the n minus 1 power, right? And same thing, we need a what? A1, then we need a common ratio in the n to find the AN, right? Then we will do the series after, okay? Let's see some more examples for the sequences first. So let's see. If we give you the first 3 terms of a sequence on your page 63, okay? It says, okay, you have to decide that is either arithmetic or geometric sequences first. Then, if it's a geo, then we'll try to find the AN and R, right? So if you have this one, 8, 16, and 24, and this one, 8, 16, and 32. You start the same thing, 8, 16, but next one is different, then you have to decide, right? So you can decide which formula you might be able to use. So for the first one is what? If times 2, that would be 16. 16 times 2 is 32, not 24. So this one is geo, right? How about this one? This one would be what? Arithmetic sequence, right? So this one is, okay, not geo. Then for this section, we are doing the geometric sequences. So let's find the AN and R. It wants us to find the patterns and the ratio. What do you think the ratio is? 16 divided by 8 is 2, right? Then AN is this formula, right? A1 times R to the n minus 1. So what do we have? A1 is 8. R is 2, n minus 1. So general patterns, you can just write this way. Okay? All right, let's see. Next one, we have 54, 36, 24. This one, same thing, started from 54, 36, and 18. So let's take a look. If it's arithmetic, we should do what? Subtraction or addition, right? Let's take a look. So this difference is what? Minus 18. This one is minus 12. So it will not work, right? For the arithmetic sequence. So this one minus 18, this one minus 18, yes. So this one is arithmetic, not geo, right? Then this one, let's see if it's geo. So then we try to figure out, can be multiplied something. So you go backwards to do the divide. Then divide, that would be divided by 8, 2/3. That would work. Okay, divided by 18. If I do this one, 24 divided by 36 divided by 12, I can get 2/3 as well. Okay, so this one is geometric sequence, right? So then let's try to find R and AN. So R is what? 2/3, right? AN would be what? Formula here, right? A1 Rn minus 1. A1 is 54, R is 2/3, right? N minus 1. So that would be your formula, right? You can see N minus 1. So that would be our sequences for geo. Let's take a look. And here is an app to talk about this. Okay, so let's see. On your page 64, it says, a real estate investment broker predicts that a certain property will increase in value 15%, okay, each year. Thus, the year property value can be modeled by a geometric sequence whose common ratio is what? 1.15. If the initial property value was $500,000, then ask you to write the first 4 terms or the sequence and predict the value at the end of the 3rd year. Okay, so $500,000 means what? Beginning of the 1st year, right? Then next year will be what? 15% more, 500,000 times 15%, 0.15, that would be 75,000 increase. But the total value would be what? Plus 500,000. Actually, is what? Times 1.5. This is a 0.15. So itself and the increased value, so that would be 575,000. That's why the R ratio is what? 1.15. So next year would be what? 575,000, right? The following year that you times 1.15, you will get 665,250, right? And next year would be what? 760, you times another one. Okay? So the question was what? Write the first 4 terms, right? Then predict the value at the end of 3rd year. So this part is not quite a math problem. Actually, it's just common sense money issues, right? End of 1st year, end of 3rd year. So 1, 2, 3, 4. Are you going to use this one or this one? It says end of 3rd year, how much the house worth, right? This is the beginning of the 1st year, beginning of 2nd year, beginning 3rd year, beginning 4th year. But which one is end of 2nd year? This one is end of 2nd year, beginning of the 1st year. Then end of 2nd year is beginning of the 3rd year. End of 3rd year is what? Beginning of the 4th year, right? So the question was what? Find the value at the end of 3rd year. End the 1st year, end the 2nd year, end the 3rd year is what? Beginning of the 4th year. So actually, the value should be this one. It's almost $100,000 difference. $100,000 difference, right? You better know how to count your money if you are a real estate agent. And you need to know the value at the beginning of the year or end of year. It's different. Beginning of year is this, end of year actually it's this one already, beginning of the second year, right? So that's how we think about the geometric sequences. How do we apply it? Okay? Okay, let's look at these series. Series means what? The sigma, right? You add things up. Series is what? A1 plus A2 plus 2AN, one type, right? Or you might have A1, this is infinite, right? A1 plus A2 plus 2AN plus forever, right? Maybe we just do that forever. Okay? The formula is this. If it's a finite series, so for finite one, let's just write it out. So if to the n, right? The formula is this: A1 times 1 to the r to the n power. It's not n minus 1, okay? So for the sum, you always count to the n, okay? Divide by 1 minus r, okay? R is not 1. And then we talk about S infinity later. Like here for arithmetic sequence, okay? Then for infinite sequences, for this one, it doesn't exist. But for geometric, it's a little bit different, okay? Then we'll talk about later. So we need to apply this formula for the geometric sequences, right? So the reason behind it, then we prove it, it will take a while, but okay, for most of you, as long as you can apply it, that's good enough. Okay, if you're interested in why it's so, then you can call me. Okay, so let's take a look at some example. So how to use the finite series formula for the geometric series, okay? So find the sum for the sixth term. 6, 12, 4, 36 for 6 terms. Okay? What do you think? We can use this formula, right? So our A1 is 4, our R is, because it's geometric sequence. So 12 divided by 4 is 3, right? Then 6 terms. That means S6, if we plug in this formula, is A1 times what? 1 minus R to the nth power, right? N is 6, right? 6. So we need to do that. Then y, 1 minus 3, right? We just plug in this formula. Then what do we have? Then you just plug in calculator. Then you should get 1, 4, 5, 6. Make sure you do that, right? Actually, when you watch this, you should do this right away. Make sure you get it before you move on. Okay? If we give you this, give you 976, say for 12, right? And on last term is 976. We ask you how many terms it is. So A1 is 4. Then you decide, do we have a geometric sequence or arithmetic sequences? right? It's geo because times what? 3. So R is 3 times 3, right? Then we want to find out how many terms there is. But we do know AN is what? 976. So for geosequences, what do you think? Which formula? We have 2 formulas for it right now. Which one you should use? We should use the sequences, right? AN equals what? A1 times R to the n minus 1, right? AN is what? 976. A1 is 4. R is 3. N minus 1. We have equations. Then we have to find the n. Look at what kind of position n is. At exponential position, right? Then you have to solve what? An exponential equation. Then how do you solve it? You have to use same base, right? So by itself, so you divide it by 4, then what do we have? That would be 2, 4, 4 equals 3 to the n minus 1. Is that right? 2, 4, 4. Is that 2, 4, 4 base 3? Doesn't look like it. Let's see. Do we copy? Oh, no wonder. I say, oh no, it's not a base 3. Actually, it's 72. Okay, then that looks much better. Okay, when you get stuck, you cannot figure out, that means there's something wrong because n should be a good number, right? Then you look back, check your typos. So you find what's the 3 to the power. You have to find out, change the same base, right? So you can do 81 and 3, right? Then 99. Do your trees. So it becomes what? 3 to the 5th power is 3 to the n minus 1. Then 5 equals n minus 1. What is your n? N is 6. That means you have 6 terms here to get a 972 as the last one. Okay? All right. Say we didn't see any of those. Then you just see this one, right? Instead, so if I have said, okay, my first term is 4. Then 1, 2, 3, 4, 5, 6. Then last term is 6th term is 972. What's your R? Right? Assume we didn't see earlier whatever we did. We just give you a question like this. How can you find R? Since we tell you it's geometric sequence, so you need to use the formula for the sequences, right? So we say A1 is 4. We don't know the R. N is what? 6. AN is 972, right? Then we use the formula, say AN equals A1 times Rn minus 1. You plug in. So AN is 972. A1 is 4. R we don't know. N is 6 minus 1. Now you start to get things mingled. So many A1, A2, Rn, AN things. Okay? So many symbols, but you need to match which is which and what do they mean. Okay? To find the R, we have to find the base. So we divide it by 4. What do we have? 2, 4, 3 equals R to the 5th power. Right? Then what's your R? then you take a fifth rule, right? 2, 4, 3, take a fifth rule, which is what? R is 3. How do you use calculator to take a fifth rule? There is no such thing as a fifth rule. But remember, fifth rule means what? 1/5 power, is that right? 1/5 power, top one is power, bottom one is the rule. Then on your calculator, you can do 2, 4, 3, take 1 divided by 5. Use this kind of symbol to get 1/5 power to get the fifth rule. Or you can do your trees. Then you get R is 3. Okay? Next one, find the sum for this. Okay, 5 terms. You can just say, oh, 5 terms. Do I have geometric sequences or do I have, arithmetic sequences? So you decide. It's not arithmetic, right? It's geo because times what? 1/4. Or you can say, oh, my next term will be half times quarter. My next term will be what? 1/8. Then you add them together. That would be 5 terms. But that's not the point, what we are doing, right? Of course, you can add the fractions. What happens if we do 100 terms? That would take you forever, okay? So we need to apply the formula, right? So we need what? A1, R, and N. So what's our A1? 32. What's our R? A divided by 32 is 1/4. We need to simplify, otherwise the calculation will be messy. Okay, we want to do 5 terms. So S5 is what? Use this one, right? A1 times 1 minus R to the nth power for the sum all the way, right? 1 minus R, total 5 terms. So A1 is what? 32. 1 minus R is what? 1/4. Total is 5 of them, right? 1 minus quarter. You need to know how to handle fractions like this, right? Otherwise, we really don't know what to say. 1 minus 1/4 to the 5th power, right? So you times whatever, you get a fractions, you subtract them and divide by 3/4. Okay, so the answer is 341/8. Make sure you get it. Right? Otherwise, we'll have to send you back to Math 152A class to start over, right? So that's how we use the geometric series to calculate the sum. Okay, so this is a finite series for the geometric series. All right, then particular one it's different from the arithmetic series because you cannot find an infinite series for that. But for geometric series, it's a little bit different story. Okay, so let's see if it's infinite. We talk about infinite geo. Okay, let's see some example first. Why infinite series has number sometimes, okay? So if we have, say, 2 plus 4 plus 8 plus 16, do I have a geometric series? Right? Adding is a series, right? So do I times 2? Yes. Okay. So when I add it together, means what? I'm doing the series. Okay? So if I have this one, let's take a look. Do I have a geometric sequence and a series which I define? Then difference is, okay, this one is a finite series. This one, oh no, both are infinite series, right? Okay, but for this one, times 2 times 2, the number is getting bigger and bigger. When you keep adding, can we find it? The answer? A fixed number to answer the question. So this one doesn't exist, right? Because the numbers are getting bigger and bigger and bigger. Then keep adding to it. However, for the next one, do we have a geometric series? By doing what? Times half this time. Okay? It behaves a little bit different. Let's do the observation. Okay. So, if I have 1/2 plus 1/4, what do I have? You just add them. 3/4, right? If I have 1/2 plus 1/4 plus 1/8, I'm just doing the sequence, right? I have 7/8. When I have 1/4, 1/8, then I do another one. I have what? 15/16, right? Then if I do one more, take a look, the pattern. We are doing the pattern recognition, right? Then we just keep adding. So what do we have? 31, 32. Okay? Then if I keep adding, see? 132, next one 164. What do you think the answer is? 6, right? So because the number is getting smaller and smaller, even you add into it, then getting close to where? Okay? It's getting bounded by, getting close to 1. Take a look. 7/8, getting bigger and bigger, but never reach the denominator, right? Getting close, but it's bounded by getting close to 1, but you will not get over. Why? Because the number is getting smaller and smaller. If you add into it, you will not go over it. Okay? Then what's the difference between these two? Mainly is this guy. The ratio. Okay? If you keep multiplying the number bigger and bigger, of course, you cannot find the answer. You will not be bounded by. However, if you multiply a number less than 1, if r, okay, it's like half or third or even negative, right? It's getting smaller and smaller, so you will the final number will approach to 0, but will not be 0 though, right? But getting smaller. So when you add the tiny numbers, you will not go over. Okay? So when for the geo series, the infinite summation, okay, infinite series, it has a limit. You can, if this one, it maybe can be written this way, it's A1 over 1 minus R. The reason because R is half, third smaller and smaller. When you n to infinity, this guy is almost 0, right? Like 1 to the third, then you say, oh, 100 times, 1,000 times, getting smaller and smaller. The more n you have to infinity, this guy is getting smaller and smaller, approach to 0, so it's gone, right? Become A1 times 1, become A1. But this is under the condition R is what? Half or third or negative, right? So this one is less than 1. If it's bigger than 1, then S infinity what? Doesn't exist if R is bigger than or equal to 1. So you have this special situation. Okay? So that's the major difference between the arithmetic sequences and geometric sequences for those series part. Okay, so you should be fine, but sometimes if you don't clarify in your head, you will mingle all of them. Okay, so first you have to decide what kind of sequences you are dealing with, either arithmetic or geometric, right? Then you decide you are handling sequences or series. Then for geo, then sequences you are fine. For series, you have another 2 types, right? One is finite, one is infinite. Finite, you follow the formulas. Then for infinite, for geo, one you have answer, one you don't. Okay, so let's see some more examples for the geo. Okay. So we are on the page where we page 65, right? Okay, so let's do some geo series. Some of them are finite, some of them are infinite. Okay, so if we have this one, when you have fractions, different denominators, most likely you have geometric sequences, right? So, but you have to check though, do you have geometric sequences and series, right? So you do 16/3 divided by 8, right? R equals what? 2/3. Okay, then, or you can do 32/9 divided by 16/3. Yes, okay, you do have 2/3 to your fraction. So yeah, okay. So we have geometric sequence. Then try to find the series, right? And when we have da 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 means what? We need to find the series. Do we have an answer? Exist? Yes. Why? Because R is what? 2/3 less than 1. Okay? So we can use the formula. Which one? Infinite, right? Because S infinity is what? A1, 1 minus R. Doing that is very easy, okay? But to decide which one to use, it takes all the understanding, right? A1 is 8. R is what? 2/3. So A divided by 1/3. So that's 24. Are we okay? Okay. So when we have dot, 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 we find the S infinite, right? Infinite series. So we have to decide, do we have a GO? Let's check. So you do what? 16 divided by -4/3, right? So what do we have? That would be 3/4 negative. Okay, or you can check -12 divided by 16, so divided by 4, so do have 3/4. Okay, so everybody is the same, so you do have R equals -3/4. So we have geometric sequence and series, right? So do I have S infinity? Yes, because what? My R is absolute value is less than 1, 3/4, right? So our S infinity, we follow the rule A1, 1 minus R. A1 is what? -64/3, right? 1 minus R is what? -3/4. Okay, so you should be able to handle that. So you should have 256/21. Right? Okay, next one. We have this 128/7 plus 1024/49 plus da da da. Right? So this is S infinity, infinite series. So first we have to decide if it's G or not. If it's arithmetic, it doesn't exist, right? Because fraction looks like GO. So R is what? 128/7 divided by 16, right? Or R is 1024/49 divided by 128/7. Okay? Then we do find out, okay, it's A7, both are A7. So we do have a GO. Okay? Then, does S infinity exist? No, it doesn't exist, right? Why? Because its absolute value is bigger than 1. Okay? Because it's bigger than 1, numbers are getting bigger and bigger and bigger. When you add it together, you cannot find the answer. That's how it works. Right? Okay. Let's see some apps. Okay, take a look at your page 66. Okay, Okay, first one. A fishing boat goes out on consecutive days, each day catching 95% of what they caught the day before. If first catch was 500 pounds, okay? Then he asks you how much did they catch on the 5th day. So first day, second, third, fourth, and 5th day, how much you will catch, rounded to the nearest pound. Is this sequence arithmetic or geometric or neither? Find the total amount of fish caught during the first 5 days, rounded to nearest pound. Okay, so let's find the 5th day. Each day will be what? Next day will be 95%. So that means what? You multiply 0.95, you do that, right? You can find the 5th day. Or we can use the formula, right? Because we have A1 is 500, right? R is what? 0.95, and is 5th, right? 5th day, how many they are, right? So you use the formula, AN equals what? A1 times Rn minus 1. You plug in for the 5th day, A1 is what? 500, R is 0.95, and 5 minus 1, right? You just plug in. So you should get around 407 pounds, okay? Then he asks you, is that a GO? Yes, the ratio is 0.95, right? Then it's finite. Finite, we should find the sum for sure, because it's a fixed, you should be able to add up. Doesn't matter you have 100 or 1,000, you should be able to, but not to the infinity, right? So we just use the formula S5, right? S5 should be what? A1 times 1, we just do the N, write it down first, 1 minus R, right? A5. So we would do, oh, here is A1. So A1 is 500, 1 minus 0.95 to the 5th power, right? 1 minus 0.95. So you will use all the decimals to calculate. Then only round it at the end, you should have 2262 pounds, somewhere there, right? Because each day 500 pounds, 5 days is 2,500 pounds, and a little bit less because 95% each day, right? And so that's how you do. Let's look the next one. A woman made 30,000 during the first year she owned her business, and made additional 10% over the previous year in each subsequent year. Find how much she made during her 8th year. Okay, rounded to the nearest penny. Is this a sequence arithmetic or geometric or neither? Find the total earning during the first 4 years. So first, find how much she made during her 8th year. So $30,000 to start. Then each year she make what? 10% more. 10% is 3,000, right? So she made 33,000, right? Actually, it's what? 1.10, right? Times 1.10. 10% is the increase, 1%. 1 is original. So you times 1.10 next year. So for the 8th year. So we don't need a 0, just 1.1 is good enough. So how do we find the 8th year? So we do A1 is 30,000, right? R is what? 1.1 for the 8th year. So we find 8A is what? A1 times R 1.1 to the n minus 1. It's a 7, right? Then you round it at the end. So she will be making such. Okay, do it on the calculator. So that would be the 8th year, almost double, right? So is this a geo? Yes, it's a geometric sequence because you multiply by 1.1. Then let's see how much total she will make for these 8 years. It's a finite series for a geometric sequence, right? So we use this. So you use A8 equals A1 is 30,000 times 1 minus R, 1.1 to the 8th power, right? Then 1 minus 1.1. Then you round it at the end to the pennies. So it's about 139,230. Make sure you do it right, okay, on the calculator, right? Are we good? So we practiced all the geometric sequences and the series. Then for the series, we have what? Finite series and infinite series. Finite series, always, you should be able to find the answer, right? Then for the infinite series, for the geo series, one of them you can find the answer, one of them you cannot for the infinite series. It depends on your R ratio. If it's getting bigger and bigger, you cannot make it. If it's, reach to very, very small at the end, then R is absolute value is less than 1, then you can find it. Okay? So infinity concept is very critical on the calculus, and a lot of people cannot get over it because that concept is very abstract. Okay? Let's look at next example, page 67. One application of geometric sequences has to do with consumer spending. If a tax rebate is given to each household, the effect on the economy is many times the amount of the individual rebate. Okay? So, because the ripple effects, if you give $1,000 for a household that will spend on certain things, then other people get this money, will spend on more things, right? So that's how they count it. So let's look. The government has decided to give $1,000 tax rebate to each household in order to stimulate the economy. The government statistics say that each household will spend 80% of the rebate in goods and services. The business and the individual who benefit from this 80% will then spend 80% of what they receive and so on. The result is called the multiplier effect. What is the total of the rebate on the economy? Okay, so it means what? If you get $1,000, then you spend 80%, then you spend $800, right? Then for this $800, then they will spend 80%, they will spend $640, right? then and on and on. Then all the money spent will be added to the economy, right? This is a multiplier effect. For the first $1,000 government, the first person get it, right? That's into the economy. The next person get $800 from what the first person they spent. So total, you have to add up, then becomes the multiplier effect forever to the infinity, actually, right? So what we are doing is, first one is 1,000, next one is what? Times 0.8, right? And next one will be what? 1,000 times 0.8 to the square, right? So each one, so your R is what? 0.8. Then we wanted to find actually is infinite series, right? A1 is 1,000, then N is infinite, right? We want to find the S infinity. Can we find this? This is a geometric sequence, right? But we want to find the infinite series. Can we find it? Yes, because R is what? Less than 1. Okay, so this one formula is what? A1 over 1 minus R. A1 is 1,000. R is 0.8. Doing that is relatively simple, right? But the thinking behind it is not that straightforward. We have to talk about everything until we get this point. Actually, it's $5,000. That means for each $1,000 stimulus check, tax rebate, the government put in, right? Then you will have what? 5 times that much effect. So the total effect of the $1,000 received by each household would be a what? $5,000 growth in the economy, 5 times that much. So they count the what? GDP, things like that. Okay, that's how they count it. Depend on this 0.8%. If it's just 50%, then you will only add on $2,000 to the economy. It depends. Okay, this ratio, common ratio, the multiplier effect, that's what we are talking about. Use this geometric series concept to deal with the economy, right? How we calculate that. Got idea? So this will be last section of this class, section 12.3.